Um, okay, so it is 11 o'clock. We are going to go ahead and get started here. So welcome everyone to Visionary Intelligence. We are going to be unveiling the future of machine vision for this year, 2024. Please turn off your video if you haven't already and open your chat, which will be found at the bottom of your screen there. And feel free to ask any questions. We're just going to hold off on questions until the end, but feel free to ask them at any time. And on to you, Jonathan.
Good morning, everyone. My name is Jonathan Hackney, and I'm the Director of Sales for the West Region. I've been an application engineer for in the manufacturing sector for over 14 years. I hold a bachelor's in science and industrial engineering from Texas Tech, and I've been with Computar for about 3 years now. So I just wanted to introduce myself to you guys. Good morning. Hello, everyone. We still have a couple of people coming in. So if it looks like I'm preoccupied, it's because I'm letting some of those people in. So let's get started. So over the 40 years, Computar has led the way in lens manufacturing, pioneering innovative optics. With a strong base in Japanese engineering and flexible production facilities worldwide, Computar remains dedicated to producing top quality optical products. In today's agenda, we'll be covering a few topics. The first is innovations in machine vision technology. The second, optics meets AI, a symbolic future. We're also going to be talking about the advancements in robotics and autonomous systems, and then we're going to dive into sector-specific impacts of machine vision. And then for our last topic, we'll be looking at the road ahead for machine vision, and then we'll hold a quick Q&A. So first, let's talk about some innovations in machine vision tech. Visual intelligence is demonstrated by the growing relationship between AI, deep learning, and machine vision systems. Machine vision systems and artificial intelligence are being used together in applications that would be too complex to maintain with traditional solutions. Deep learning methods enable the analysis of image data in machine vision systems, leading to a more advanced and efficient processes. Artificial intelligence requires a holistic view of all the machine vision data to compare and develop against, indicating a strong interdependence between AI, deep learning, and machine vision. So next, let's see how visual intelligence is disrupting industries across the globe. AI, deep learning, and machine vision systems are poised to disrupt traditional industries by streamlining automation processes and refining quality control. The first example of industry change is improved efficiency. The use of deep learning and AI and machine vision systems enables more efficient and accurate automation processes. This leads to increased productivity and reduced operational costs, making traditional industries more competitive and agile. The second example is enhanced quality control. By leveraging AI and deep learning, machine vision systems can detect defects and anomalies with greater precision and speed, leading to improved quality control measures. This ensures that products meet the highest standards and reduce the likelihoods of defects reaching the market. The next example we want to bring to light is predictive maintenance. So AI-powered machine vision systems can analyze data to predict potential equipment failures and maintenance needs, enabling proactive maintenance and reducing downtime in traditional industries. For the final example of industry influence is customization and personalization. So the integration of AI and machine vision systems allows for greater customization, and personalization of products, meeting the evolving demands of consumers in traditional industries. Now let's talk about the advancements in robotics and autonomous systems. We are seeing a growing increase in AI integration. So machine vision technology is integrating AI and deep learning to enhance capabilities of robotics and autonomous systems. Next, there's been a massive advancement in perception and sensing. Machine vision empowers robots and autonomous systems to perceive their surroundings using visual data, facilitating real-time decision-making and navigation through intricate environments. The next giant leap we have seen is in object recognition and localization. Machine vision technology allows systems to recognize objects, identify patterns, and accurately locate targets, which is essential for tasks such as pick and place operation, navigation, and obstacle avoidance. And finally, adaptive control and feedback. By integrating machine vision, autonomous systems can adjust their behavior based on visual feedback, enabling them to adapt to changing conditions and perform tasks with greater precision and reliability. So, what are some of the challenges in advancing the autonomy of systems using machine visions? Well, the first is maintaining robustness and reliability. One of the biggest challenges for machine vision is ensuring that systems can operate reliably in diverse and dynamic environments. This includes low light conditions, varying textures, and unpredictable scenarios. The next challenge is data processing and computation. Managing the computational demands for processing large volumes of visual data in real time while maintaining low latency and high accuracy. The next hurdle is interoperability and integration. Machine vision requires integration with other sensor configurations and control systems to create seamless and cohesive autonomy. This requires standardization and compatibility across different software platforms and other technologies. And finally, ethical and legal considerations. So addressing ethical and legal implications related to privacy, security, and accountability when deploying autonomous systems in public spaces and commercial settings. So the meat and potatoes of this challenge includes privacy invasion, surveillance, bias, discrimination, accountability, job displacement, security, access, and regulatory frameworks. Other challenges in this area may include safeguarding human rights and societal well-being. To solve these challenges, the industry needs to take the initiative to develop ethical guidelines and standards that mitigate the bias, protect privacy, promote education and awareness, and establish regulatory frameworks, ensure inclusivity and accessibility, and foster collaboration amongst stakeholders. By addressing these challenges, machine vision technology can continue to grow and drive an advancing of autonomy in robotics and autonomous systems, unlocking new possibilities for automation and intelligent decision making. So now let's talk about some sector-specific impacts of machine vision. So the first is the manufacturing sector. Machine vision creates smart factories and optimizes production lines. So the first impact that we'll talk about is the quality and inspection and defect detection. Machine vision systems can inspect, analyze products in real time, identify defects, identify non-conformance and high accuracy. This ensures the only high-quality products reach the market, reducing waste and rework. The next impact is in process monitoring and control. So machine vision technology allows for real-time monitoring of manufacturing processes, enabling proactive adjustments and optimizations to maintain consistent quality and efficiency throughout production lines. The next is traceability and compliance. Machine vision systems can track and trace products throughout the production line, providing valuable data for compliance with industry regulations, supply chain management, and product authentication. The next, automation and robotics integration. By providing visual perception and intelligence, machine vision technology enables the seamless integration of automatic automation and robotics into manufacturing processes, leading to increased productivity and flexibility. And the last major impact of machine vision is data analytics and predictive maintenance. Machine vision systems generate valuable data that can be analyzed to optimize production efficiency, predict maintenance needs, and identify opportunities for process improvement. Next, let's talk about the healthcare sector. Machine vision plays a critical role in driving innovation in medical diagnostics through enhancing imaging and analysis capabilities. The first example is in medical imaging and diagnostics. Machine vision enables the acquisition and analysis of medical images such as X-rays, MRI scans, and CT scans to assist in the diagnosis and treatment of various medical conditions. The next major impact of machine vision is in the image analysis and pattern recognition. Machine vision algorithms can analyze medical images to detect anomalies, identify patterns, and assist healthcare professionals in diagnosing disease and condition with greater accuracy and efficiency. Machine vision has become increasingly important with surgical guidance and robotics. Machine vision systems are used to guide surgical procedures and assist in robotic surgeries by providing real-time visual feedback and navigation assistance to surgeons, leading to improved precision and patient outcomes. The next advancement caused by the growth of machine vision is early detection and screening. Machine vision technology can aid in the early detection of screening of diseases by analyzing medical images and identifying subtle changes that may indicate the presence of abnormalities. Sorry, get a little choked up here. And the final example is the personalization, medicine, and treatment planning. Medical images and genetic data can be analyzed to tailor treatment plans and interventions based on individual patients' characteristics. By leveraging machine vision technology, healthcare professionals can benefit from improving images, analysis, and diagnostics capabilities, leading to more accurate diagnosis, optimized treatment plans, and better patient care. This next sector has huge potential: transportation. Machine vision plays a crucial role in the development and safety of self-driving vehicles. The first example is perception and object recognition. Machine vision systems provide self-driving vehicles with the ability to perceive and recognize objects, pedestrians, road signs, and other vehicles, enabling them to navigate and make decisions based on real-time visual data. Next is environment mapping and localization. Machine vision technology enables self-driving vehicles to create detailed maps of their surroundings and accurately determine their position and orientation within the environment, essential for safe and precision navigation. Another crucial role is obstacle detection and collision avoidance. Machine vision systems can detect and track potential obstacles and hazards in the vehicle's path, allowing for proactive collision avoidance maneuvers and enhancing overall safety. Adaptive cruise control and lane keeping. Machine vision's capabilities enable self-driving vehicles to maintain safe distances from other vehicles as well as stay within designated lanes, contributing to improved traffic flow and reduced driver fatigue. And finally, enhance safety and redundancy. Machine vision technology provides an additional layer of safety and redundancy in self-driving vehicles, complementing other sensor configurations and control systems to ensure robust and reliable autonomous operation. By leveraging machine vision, self-driving vehicles can achieve a high level of autonomy, safety, and efficiency, paving the way for future of transportation and mobility. So for this next slide, I'm going to talk about a little case study, is application from a recent application from an Alberta, Canada customer. They utilized an aerial drone to equip our cutting edge MPT Series lens, and they captured high resolution images of raging forest fires in the area. So these precise images assisted first responders in mapping out the heat and direction of the fires. The captured data enabled the responders to access the blaze and take steps necessary to mitigate damage caused by it. So these are just some other case studies we wanted to talk about and kind of bring to your attention, maybe to get the juices flowing from some of your applications. So let's talk about the road ahead for machine vision. But first, let's look at a snapshot of then and now. So in the 1930s, we have the electronic sorting machines that were invented at the bottom of the screen here. In the 1980s, smart cameras were invented. In 2006, machine vision had a 3.1 billion global market. In the 2010s, the term machine vision began rising in popularity. In 2023, the global market was valued at $9.8 billion. And what are our projections for 2030? Due to continuous rising popularity in AI, deep learning, and overall smoother, more efficient processes, the global machine vision market is expected to grow to nearly $16.8 billion by 2030. And we can provide any of these links that you need, so we can so you can check this information out for yourself. So where are we heading, and what are some predictions for the future landscape of machine vision? Well, the first is significant growth. So machine vision usage is projected to grow by 37%, indicating a substantial increase in the adoption and application of machine vision technology across various industries. Another prediction is expanding sensing capabilities. So future vision systems may capture not only visible light, but also infrared, IR, and ultraviolet, UV wavelengths, enhancing the range and depth of visual data processing. Other examples of advancement in 3D time-of-flight sensors as well, and SWIR technology. And one of our last prediction here is the market expansion. So the global machine vision systems market size is expected to experience significant growth, reaching a substantial value by 2030, reflecting the increasing demand and investment in machine vision technology. These predictions suggest a promising future for machine vision technology, characterized by growth, technological advancements, and expanded applications across diverse domains. So let's talk about lens technology that is crucial for visionary intelligence. When setting up your automated vision systems, the lens may be the last component you choose. However, once your system is up and running, your data flows from the lens first. That makes lens choice one of the most impactful decisions affecting how well your vision system works. Visionary intelligence is enhanced with Computar's 45 megapixel MPT series lens technology and its significance in achieving unparalleled image detail. Some of its features include ultra low distortion, engineered to minimize distortion, ensuring that captured images are faithfully represented of the inspected object. This is crucial for applications where accurate measurements, defect detection, quality control rely on distortion-free imaging. Another feature is the compact design. The compact design allows for seamless integration in machine vision systems, making them suitable for space-constrained environments and applications where portability and flexibility are essential. It has amazing high resolution imaging, 45 megapixel resolution, and lens options ranging from 12 millimeter to 50 millimeter focal lengths, and then enable the capture of fine details and precise visual data essential for crucial inspection and analysis tasks. It also has a large format sensor compatibility. The C-mount lens design is optimized for 1.4-inch large format sensors, ensuring compatibility with modern high-resolution imaging sensors commonly used in machine vision applications. The benefits of the MPT series include enhanced accuracy. The low distortion and high resolution imaging capabilities contribute to improved accuracy in visual inspection and measurement tasks, allowing for precise analysis and reliable decision making based on captured visual data. The MPT allows for detailed visual analysis. The advanced optics enable detailed visual analysis of objects, components, surfaces, making it suitable for applications that require meticulous examination and detection of fine defects or anomalies. This is especially important for quality control and assurance. The MPT helps your vision systems facilitate the accurate inspection in industrial settings for manufactured products, components, and materials, ensuring compliance with stringent quality details. Its unmatched versatility is suited for a wide range of machine vision applications, including robotics, automation, medical imaging, semiconductor inspection, and more, where precision and clarity are paramount. So that's a little on the MPT series. Now we were going to talk and do a little Q&A. There is a chat box. If you want to ask questions, please go ahead. Let's send us any of the questions. If we can't answer them today, we can get back to you with email or whatnot. And I've got a couple of frequently asked questions that I can go through while you guys kind of write down your questions here. One of the frequently asked questions from one of our clients was, how does the floating design work in a lens? So I wanted to kind of go over that a little bit, and you guys can fill in the chat box. But a floating lens design is helpful for optics in several reasons. And the first is aberration correction. So floating lens design helps correct optical aberrations such as spherical aberrations and coma across a range of focus distances by allowing specific lenses elements to move independently within the optical system. Aberrations can be minimized. The other reason why they're helpful is improved performance. So a floating lens design can enhance the overall performance of optical systems, especially in close focus situations. The other thing it does is reduce curvature, resulting in sharper imaging, and also helps minimize distortion, like barrel or pin cushion type distortion. So overall floating lens designs allows for greater flexibility and precision in optical systems. So what format are the lenses? So they're probably talking about the MPT lenses. So our MPT lens is a 1.4-inch formatted lens, C-mount lens, 45 megapixel. We kind of just went over it, but if anybody has any other questions they kind of want to throw out there, I'll be glad to take them. Let's check the chat here.
Yeah, we've got a couple questions. So Shmuel asked what model was used to project the 2030 market size. And I will let you know that I will send out the sources after this with the presentation so that you can look into that yourself. But judging from like my research, they didn't mention the exact model. And then could the MPT series support larger than a 1/4 inch with custom mechanics and threading?
Well, it is designated for 1.4 inch and 4/3 as well. Um, but with custom threading mechanics, if you're trying to go for a larger type image sensor, you might have some vignetting as well. But Sean, I can definitely take your question to some of our optical engineers, and we can get a precise answer for you as well. If you want to just post your email address, I could probably look you up and shoot you an email on that question.
Um, and then, by the way, if you are feeling shy, you can always directly message me, Computar Optics, or Jonathan J. Hackney. So we did get a couple questions in here. What is the minimum working distance for the MPT?
Okay, so yeah, the minimum working distance for the MPT, it's going to be 0.15 meters or about 150 millimeters, and then out to infinity for the working distance on that guy.
And is the MPT series the only machine vision lens Computar has?
No, so we actually have the MPZ series, which is an 8 to 75 millimeter focal length and a 1 inch image sensor size. So it's 1 inch, and it gives you a little bit more versatility. It is a really great lens, very common lens that we get a lot. We also have the MPW3 series, which covers smaller 2/3 inch image sensors. And then we just recently released the MPX series, which is a 2/3 16 megapixel 10G anti-vibration and shock resistant design. So really cool lens. So definitely for robotics, maybe robot arms or environments where you have a lot of vibration. Maybe your lens or your camera system ends up failing because of that vibration. This is definitely something to take a look at, this anti-shock resistant lens design. And that unit comes in 8 millimeter to 75 millimeter focal lengths. And then we also have a whole series, and that's all manual. Um, those are all driven manually, so you adjust the focus and the iris manually. We also have the Lens Connect series that we're using for some robotic applications and machine vision applications. And the Lens Connect series allows you to change the focus, the zoom, and the iris all with a USB connection. So all remote controlled type lenses, really cool stuff. So if anybody else has any questions, definitely let me
Yes.
know. Or
Yeah, we've got a
the other
couple
thing.
more.
Okay, yeah, sure.
Sorry. What anti-reflection coatings or features are used with swirl lenses, and are there any specific tests done to measure the effectiveness of these?
Yeah, sure. Thanks for your question, Greg. So yeah, we do put an anti-reflection coating. There are also little things that we do within the lens, like we black out the lens so we don't get those aberrations and stuff like that. With our SWIR specifically, not only do we do the coating, but the lens element itself is special proprietary. I can send you the MTF graphs, Greg, on two of our series. We have the Light series and the Hyper APO SWIR series, which we call VisSWIR. And what's great about that Hyper APO is there's no focus shift when you're switching from visible to SWIR. And we do all that, the coding, and like I said, the lens elements and other parts on the actual lens are all engineered to minimize those reflections. So um, on the screen is actually my email, jhackney@cvcamerica.com. com, and then that's my cell phone number. If anyone has maybe a bigger question, they want to send an email, send it to me, and we can work with you.
Do we do any custom design work?
Any custom design work? It definitely depends on how big the project is and what the project is. If you can, my email is right there. If you can send me an email, that way we can we can correspond and I can learn more about your project, and we can see what we can come up with. If we don't have specific wins already for you, or see what we can do or what your needs are, I can also maybe point you in the right direction if it's something that we can't do. But, we certainly love to help you out and earn your business. So.
Okay, thank you, Jonathan.
All right, thank you.
All right, thanks everyone. We really appreciate you signing up and joining us today. Like I said, I'll be sending out the presentation along with our sources if you want to do some further research into the machine vision markets. And please join us next time for our next webinar. We'll be marketing that shortly. Thanks. Bye.
Thank you.
Thank you, guys. Thank you for showing up.